So this video is going to go through the first type of free response question that you guys are going to see on the AP exam, and that's free response questions involving interpreting graphs. So before we go through a couple of practice questions, let's overview what these types of FRQs look like, and then some tips on how to approach them. And then I'm going to go through two examples in this video. So the basic idea behind these questions is that we're determining info about a function from the graph of the derivative, typically. And that's going to be represented a few different ways. Some key things you'll need to be able to do is find relative and absolute extrema, like relative max, relative min, absolute max, absolute min. Determine behavior. Okay, that is like when a function's increasing, decreasing, concave up, concave down, points of inflection. Those are pretty common questions as well. Evaluate the integral from the area. So use a little bit of geometry to evaluate what the value of an integral is. And then most importantly, because this tends to show up in most of these questions, is that if I have a function defined as this, if I define g of a, or g of x as g of a plus the integral from a to t of f of t dt, what we can do here is take the derivative of both sides to come to the following relationship. Okay, and a lot of the questions you'll actually have to do this, be able to go from here to here. Okay, so let's go through our first example. So FRQ number 1. So here we have the graph of the derivative of f, and we're asked a few different questions about it. So if we know that this graph here represents the derivative of f, let's start by finding f of negative 6 and f of 5. Okay, and I'll do that over here on the right. So we know that the fundamental theorem of calculus tells us that the integral from a to b of f prime of x dx is equal to the value of f at b minus the value of f at a. Well, really what we're going to do here is kind of rearrange this to solve this for f of b. Okay, so f of b is then equal to f of a plus the integral from a to b of the derivative of f of x dx. Okay, and this right here, this second form, is what we're really going to use to solve question A. So if I want to evaluate f of negative 6, I'm really going to take the starting point that we're given, f of negative 2, and I'm going to add to it the integral from negative 2 to negative 6 of the derivative of f of x dx. Okay, and this is going to help us evaluate what f of negative 6 is. So before we do that, let's rewrite f of negative 2. We know that's equal to 7 plus the integral from negative 2 to negative 6 f prime dx. Okay, and then how we integrate the derivative of f is we're going to look at the graph here. So the integral from negative 2 to 6, well, typically when we're evaluating integrals, we want the lower number to come first, especially if we're referring it to the graph. And if we switch the order here, that's going to change the sign of the integral to a negative. And so these are two equivalent statements. So the integral, the positive integral, is going to be the same thing as the negative integral if we flip the limits of integration. So now let's evaluate the integral by looking at the area under the curve from -6 to 2. So this integral right here is going to be equal to this area, the area of this triangle, because the integral represents the area under the curve. And so this is equivalent to 7 minus, parentheses, well, it's going to be 1/2 times the base, that's going to be a base of 4, times the height, which is the y value, 2. So we end up with 7 minus, the 2's will, the 1/2 and the 2 will cancel. 7 minus 4 is equal to 3. So that's going to be the value of f of -6. Let's do the same thing with f of 5. So f of 5, I'll do it over here. F of 5 is going to be equal to, same exact thing, we do our starting point, which is typically going to be given to us, plus the integral from -2 to 5 of f prime of x dx. Okay, so notice in this case we're integrating from left to right, not right to left, so we can actually just keep our integral the same. We don't have to change the limits of integration. So this becomes +7 plus the integral from -2 to 5 f prime of x dx. Okay, and so the integral here is going to be equal to the area under the curve from -2 to 5. Okay, and that's going to be represented by these. We actually have two different segments we have to deal with. This segment here, and then this segment right here. Remember, if it goes below the x-axis, the value is going to be negative. So this integral will become 7 plus, well, it's going to be a minus now, so -1/2, because it's half a circle, pi times the radius, which is 2, squared. So that's the first segment, that semicircle, and we're going to add to it the area of the triangle. So 1/2 the base, which is 3, times the height, which is 2. Okay, now let's simplify this. So we get 7 plus minus 2 pi, so minus 2 pi, plus 3, and we can add the 7 and the 3, and we get 10 minus 2 pi, and that's going to be the value of f of 5. Okay, so that's letter A. So the most important thing to recognize is we have our starting point, and then you integrate from the starting point to whatever value of the function we want to evaluate. So the starting point to, in this case, -6. All right, let's go through this next one. So where is the function increasing? Okay, so letter B. So f is increasing. This is a property of derivatives when the derivative, f prime, is positive. So the value of the function will be increasing when the value of the derivative is positive. We have the graph of the derivative, so what I'm going to do is scroll back up here, and we're going to determine the values of x where the derivative is positive, so the values where the derivative is above the x-axis. Well, that's going to be here. So this is -6 to -2, and then right here, which is 2. It looks like 1, 2, 3, 2 to 5. And so these are going to be the two segments where the derivative is positive. Therefore, these are the two segments where the original function is increasing. And so the two answers here, the two segments, is -6, comma -2. And then it was 2 to 5. Okay. All right. Letter C wants us to find the absolute minimum on the closed interval -6 to 5. Whenever you're asked to find the absolute value of something, or the absolute maximum or absolute minimum, what I would encourage you to do is make a table and start by writing the two endpoints that we're dealing with. So this is x, and we want the maximum of f of x. So when we're finding the absolute maximum, remember we have to find in this case the absolute minimum. We have to find the relative minimum and then compare it to the endpoints. So what I'm going to start by doing is taking the two endpoints, and let's evaluate what these are. So the first one is -6 and then 5. Well, we already evaluated these two numbers in the first question, so the absolute minimum could be here at -6, which we defined as 3, or it could be here. But we have to check one more point, and that's going to be the relative minimum. Okay, the relative minimum is where f prime goes from negative to positive, and that's going to be the third point we're going to check. So let's go back to our graph here, and let's determine where the derivative goes from a negative value to a positive value. So right here, the derivative goes from negative to positive, and so there's going to be a relative minimum at 2. So x equals 2. And so what we need to do here is determine what f of 2 is, and then compare it with the two endpoints. So our relative minimum occurs at x equals 2. Let's evaluate f of 2 by plugging it into this equation here. Okay, same as before, except we're evaluating the function at a different x value. So this becomes 7 plus the area under the curve from -2 to 2. Okay, so I'm going to scroll back up. So the area under the curve from -2 to 2 is going to be the area of that semicircle here. Okay, it's going to be a negative value. So it's going to be plus 1/2 pi times 2 squared. So plus negative 1/2 pi times 2 squared. And so the value of the function at 2 is going to be 7 minus 2 pi. So 7 minus 2 pi. Okay, so all we need to do now is just compare which one has the smallest value, and that's going to be this one right here. So the minimum value is at 2 comma 7 minus 2 pi. So remember, whenever you find the absolute maximum or absolute minimum, you have to check the endpoints and the relative extrema. All right, let's finish up this FRQ by going through the last question, and that is evaluating the second derivatives at -5 and 3. Okay, the second derivative is the slope of the derivative, so what we're going to be doing is we're going to be finding the slope of this graph at -5 and 3. So let's start by finding the derivative at the derivative of the derivative at -5, and that we're going to find that by taking the slope of this line right here. The x value is located at the x value -5 is located on this red line, and so we're going to find f prime of -5 by determining the derivative of, or the slope of this line. So down here I'll do that. So f double prime at -5 is going to be equal to, it's going to be the rise over the run. And so minus 0 minus 2 over 5 minus 3. We end up with negative 2 over 2, which is negative 1. So that's the slope of the function, the slope of the derivative at negative 5. And let's do the slope at 3. Well, if you notice on the graph, there's a corner non-differentiability here at x equals 3. And so what that means is if there's a corner non-differentiability, the function is not differentiable at 3. So the graph of the derivative of f, shown here, exists at 3, but the derivative of the derivative will not exist because the graph of the derivative is non-differentiable. Okay? So what we can do here is just say the second derivative does not exist because f prime is non-differentiable. At x equals 3. Okay, and if you want to see the scoring allocation here, here's kind of the mark scheme. If you want to just pause the video and take a look at that. Okay, let's go through the second FRQ. Okay, very similar question. In this case, we have a function f. It is defined on the closed interval negative 6 to 5, and we're going to be asked a couple questions about this graph. So we're going to start by evaluating the value of the integral from negative 6 to positive 5. All right, let's start here. So we know the value of the integral from negative 6 to 5 is equal to 7. But what the question's really asking is we want the integral from negative 6 to negative 2. Okay? Let's start by doing the following. We know that the entire integral can be broken up into two integrals. So this is a property of definite integrals where we can break the integral up into two parts. And we know the value of the integral from negative 6 to 5 is 7. So we can rearrange this a little bit. So we have 7 is equal to the integral from negative 6 to negative 2 f of x dx plus the integral from negative 2 to 5 of f of x dx. And let's solve this for this term right here. So I'm going to subtract the integral from negative 2 to 5. So our answer for this first part, this integral, is going to be equal to 7 minus the integral from negative 2 to 5 of f of x dx. Okay, and the question is, how are we going to evaluate this right here? This is what we want to evaluate. And we're going to use the graph to do that. Okay, so to evaluate this integral, we're going to find the area under the curve of this graph from negative 2 to positive 5. All right, to do that, we're going to find this area here, this area here, this area, and then this whole thing right here. Okay. To make life a little bit easier, let's recognize a couple things in that. That is that these will cancel. Okay, so those two segments cancel. And these will cancel as well. This region in red and then this region over here in red will also these will cancel with each other. And so really what we're looking for is just the area in blue. Okay, so we want this area. Okay, we're going to do a little bit of geometry here. Well, we can start by, sorry, I keep erasing this and writing it again. Well, this is 1, an area of 1. This is also going to be another area of 1 when you add those two sections up, you get a whole square. And then we want to find this area by using the area of the circle. So this integral will become 7 minus we get 2 plus the area of this whole square here, which is 9, minus a fourth of the circle with a radius of 3. Okay, so there's a lot going on, but we can simplify this. So this becomes 7 minus 2. Well, let's actually just simplify what's inside the parentheses first. So we get 2 plus 9 minus 9/4 pi. So we get 7 minus 11 minus 9/4 pi. And then the answer for this question is going to be this becomes plus 9/4 pi. So it becomes 9/4 pi minus 4. And so that's the answer for this first question. So it's a tricky question because it involves quite a bit of geometry, properties of different integrals, and there's just like a lot of terms you have to deal with. Okay, so there's the answer for the first one. Let's go through the second one, letter B. There's a few different ways we can approach this one, but we just want to evaluate this integral. Okay. So what we can do here is, let's factor out the 2, and then recognize that the 4 is actually inside the integral statement. So we are actually taking the integral of 4, and what I want to do is let's write this as 2 different integrals, just to make that clear. Well, we know the fundamental theorem of calculus tells us that the integral of the derivative is equal to the original function, and so this is equivalent to, well, let's write it in a couple different steps. This is equal to the value of the original function evaluated from 3 to 5, plus, well, if we want to find the integral of the function y equals 4, that's just going to be the area under the curve from 3 to 5 of 4. So essentially what we're doing is we're doing the area of the rectangle with a base of 2 and a height of 4, and so that's going to be a value of 8. Now let's plug in the upper bound, which is 5, subtract what we get when we plug in the lower bound, which is 3. Now we're going to use the graph at the top to evaluate what f of 5 is and what f of 3 is as well. So f of 5 is going to be the y value when x equals 5. That's 0. And then f of 3 is the y value when x equals 3, and that's actually given to us down here. So let's plug those values in. This is 0 minus 3 minus square root of 5 plus 8. So it becomes 2 times minus 3 plus root 5 plus 8. So we get minus 6 plus 2 root 5 plus 8. And then the negative 6 and 8 can combine together. So we get 2 plus 2 square root of 5. And that's the answer for letter B. All right, let's go through letter C. So letter C is another absolute maximum question. And so again, what I would encourage you to do for this one is just start by plugging in the endpoints. It's an absolute extrema question. So we're going to make a table here, and we're going to plug in first the endpoints of the table. So this is x, and this is g of x, where g of x is defined as the integral of f of x. So the lower bound of our endpoint, our interval is -2, the upper bound is 5. Okay, let's start there. So if we plug in -2, we get the integral from -2 to -2 of f of t dt, Well, the integral of a value to itself is always going to be 0. Okay, so negative 2 is equal to, the y value is equal to 0. If we plug in 5, here as the upper bound, well, this is just going to be what we evaluated right here. Because all this work we did in letter A was actually evaluating the integral from negative 2 to 5. So this integral is 9/4 pi minus 4. Okay, and that's the value of g of x at x equals 5. The tricky part is going to come by finding using the relative maximum. So here is how we define g of x. So g of x is equal to the integral from negative 2 to x of f of t dt. And the relative maximum will occur when the derivative goes from a negative value to a positive value. So let's find the value where the derivative is equal to 0. So if I take the derivative of the left-hand side, it's g prime. The derivative of the right-hand side, using the fundamental theorem of calculus, is f prime. Or f of x, sorry, just f of x. And so we want to figure out where the value of g, which is equal to the value of f, is equal to 0. So f is given as the graph above, so we want to figure out where the graph goes from a positive value to a negative value. So the relative max. We want to figure out where g prime equals f goes from positive to negative. Okay, let's figure out what that x value is going to be. So it goes from positive to negative right here at x equals negative 1. And so negative 1 is going to be the value that we want to check for our relative maximum. All right, so to do that, we're going to plug in negative 1 into this integral. All right, and we're going to use the function at the top to evaluate what that integral is going to be. It's actually going to be with respect to x here. So the integral from negative 2 to negative 1 is going to be this area. Well, it has a base of 1 and a height of 1. It's half that, so that the value should be 1/2. So this integral is equal to 1/2. And so negative 1, the y value is 1/2. So the question is, which one of these has the largest value? Is it 0, negative 1/2, or sorry, 1/2, or this value right here? Okay, and the absolute maximum is going to occur at x equals 5 because you can go through the arithmetic here, but you will end up with a value that's a little bit larger than 1/2 here. Okay. Now, last question wants us to evaluate this limit here. And so the value of the limit can be found by plugging in x equals 1 into the numerator and the denominator. One little mistake I just realized I made is that this right here is not actually the integral from negative 2 to 5. It's this value right here. This is the correct value here. Sorry about that. So that's the value we want to use. Minus. So this is the absolute max. We can write it like this: 5, 11 minus 9/4 pi. so lastly, we're going to do letter D. So the limit as x approaches 1 of 10 to the x minus 3 f prime of x over f of x minus arctan of x. So the first thing you always want to do when you're evaluating a limit is just plug in the value that x is approaching. And let's see if we can evaluate this. So 10 to the first is 10 minus the derivative of f at 1. Well, that's going to be the slope of our graph above at 1. So the slope when x equals 1 is going to be the slope of this line. And the rise of this is 4, the run is 2, so the slope of this line is 2. So m equals 2. So f prime of 1 is equal to 2 over the value of the function at 1. So now we have to go back to the graph. So the value of the function at 1 is going to be a y value when x equals 1. And that's going to be also 1. So 1 comma 1. So we're going to plug in 1 here. And then arctan of 1 is the value on the theta value that gives you a ratio of 1. And that's going to be pi over 4. Because that pi over 4, sine and cosine have the same value. So we get 10 minus 6 over 1 minus pi over 4. So we can leave our answer like this. Okay. So let me put up the answer key so you guys can check your work. And there's the mark scheme for this question.